Morning, Trig. This is lesson 58, and so there are two big parts of this section. We're going to jump right in. So the first part is how to find the distance from a point to a line, and we're going to jump right in, and then I'll give you the steps if you're interested. So the directions: find the distance between point -3, 5, and the line y equals 1/2 x plus 1. All right, so if you could picture this visually, I've got, let's just say I have a point and a line, and I am looking for the distance. And so the easiest way to find that distance is to find a line perpendicular and then find a point on that line and then calculate the distance. So here are our steps. The first thing I'm going to do is find the equation of the line perpendicular and containing our point. So I'm going to find this equation that is perpendicular to the equation they gave me but contains my point. And then I will find where these two intersect, and then I can find the distance. So if this is my line, then the slope perpendicular to it, right, would be -2. It would be the negative reciprocal. And so now I'm going to use point slope form. So y minus my y value equals my slope times x minus my x value. And so this is going to become positive. And so I have y equals -2x minus 6, and then I would add 5 to the other side. So y equals -2x minus 1. The second step I'm going to do is I'm going to calculate the point of intersection between the two lines. Okay, so I'm now looking at this equation and this equation, and I want to know where the two intersect, because once I find where they intersect, I can use the distance formula between the 2 points. So the easiest way here is to set these equal to each other, right? I have a statement for y. You can use, it's technically substitution, but I'm going to set them equal to each other. So I have 1/2 x plus 1 equals -2x minus 1. And hopefully you can see what I did. I just plugged one of these equations into y because I have a y equals statement. So this is step 2. If it helps, here is step 1. Now I'm on to step 2. I'm setting them equal. I can title these steps. And so now I'm going to solve. So I'm going to add 2x to both sides and subtract 1. And so I have 1.5x equals -2. And let me make sure I have that right. Yep. And then I'm going to divide by 1.5, and I get x equals -0.8. And then I'm going to substitute that back in, right, to find y. So y equals 1/2 times x, and so for y I get 0.6. And so I now have this point, -0.8, and a positive 0.6. And so step 3 is to find the distance between the 2 points. And so I'm going to do that here. And I have the point they originally gave me and the point we just calculated, which is the point in which those two equations intersect. So I'm going to find the distance. My blue pen is running out. Sorry, let me grab another one. between negative 3, 5 and negative 0.8 and 0.6. And so I'm going to plug that into my distance formula, right? My distance formula is the difference in your y values squared plus the difference in my x values squared. You're looking for the distance between the two. That is why I'm subtracting. And so I'm going to grab a calculator. Right, this becomes a plus sign. And so I'm going to get distance equals, and I'm just going to put everything in parentheses. 5 minus 0.6 squared plus negative 3 plus 0.8 squared. And I get 24.2. You can do the calculations. And so if I take the square root of that, I get the distance is 4.92 units. And so that is the answer to this problem. Hopefully you can see I labeled those steps. So we're going to do one more, and then I will move on to the second part of our lesson. So next one, find the distance between negative 1, 5 and y equals negative 1/3 x plus 4. So I will still label my steps. Step 1 is to find the equation perpendicular to this one. And so I like to label perpendicular slope equals the opposite, so it'll be positive, and then reciprocal would be 3/1. I'm using this point and point slope form, so y minus 5 equals my slope times x minus my x value, right? X minus a negative 1 would produce, sorry, there's a glare there, positive. So y equals 3x plus 3, and then I would add 5 to the other side. So my equation is 3x plus 8. Step 2, I'm going to set my equations equal to each other. So negative 1/3 x plus 4 is equal to 3x plus 8. I'm using substitution. I'm substituting this statement in for y. Okay, so that's how I got this. And then I'm going to solve this. So I'm going to, doesn't matter which you move, so minus 3x, and then I'm going to subtract 4. I get negative 3 1/3 x equals 4. And then I divided, and I got x equals negative 1.2. So I just divided 4 divided by negative 3 point, and I put as many 3's there as possible, and I got negative 1.2. I'm going to substitute that back in to find y. So y equals 3 times negative 1.2 plus 8. Whoops. There should be. So I'm substituting that back in, and I found that y equals 4.4. So I now have two pairs of points. I have negative 1.2 and 4.4 and negative 1, 5. So I can now calculate the distance between the two sets of points. So the distance in my y, or the difference in my y values squared plus the difference in my x values squared. That becomes positive because it's a positive subtracting a negative. I got the distance of the square root of 0.4 when I simplified that. 5 minus 4.4 squared plus negative 1 plus 1.2 squared. Whoops. And I got 0.4. I take the square root, and I got the distance is 0.63. Okay, so hopefully the steps helped you. Those are the same steps you will use for those types of problems. Now moving on to 58.b. And we are back on graphing. And this section here covers narrow and wide parabolas. So let's go over the vertex form. Y equals plus or minus a times x minus h squared plus k. Let's go over what I know. I know that if a is positive, if I have a positive a, my graph points up. If I have a negative a, my graph points down. And I know that my vertex is whatever h comma k is. Now, a also determines how wide or narrow the graph is. So if a is greater than 1, it stretches the graph vertically, making it narrow. If a is greater than 0 but less than 1, so a decimal like 0.5, 0.75, 3/4, 1/3, if it's a decimal or fraction between 0 and 1, then it shrinks it vertically, which makes it more wide. Now, I like to show you, how I graph it, my little shortcut, and I'm going to demonstrate that here as well. So y equals our parent function, y equals 2x squared, y equals 1/2 x squared. And so you can see the effect of a number greater than 1, an a value, and a value that is greater than 0 but less than 1. So using my method, hopefully I left enough. That was probably pretty foolish. Yep, of me. Hold on. And then okay, so here we go. I know that in my parent function, right, numbers squared, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. This is my parent function. So if I go over, here's my vertex at 0, 0. If I go to the left 2, 2 squared is 4. If I go to the left 1, 1 squared is 1. To the right 1, 1 squared is 1. To the right 2, 2 squared is 4. So here is my parent function. This is the standard form of a parabola. I can keep going, right? 3 squared would be 9. I just didn't want a very large graph. Now let's look at what happens when a is 2. So here's my vertex at 0, 0. If I go to the right 1, 1 squared is 1, but I'm multiplying that by 2. So 1 times 2 is 2. If x is 2, 2 squared is 4, but 4 times 2 is 8. So my original point should be at 1, but I have now multiplied it by the 2. And so multiplying it stretches the points up. And so you'll see that it made the graph more narrow. And the greater the value is, the skinnier or more narrow it is. So if this was a 3, this point, instead of x, 1 squared is 1, it'd be up 3. 2 squared is 4, but it'd be 4 times 3, so it'd be way up here at 12. So it shrinks the graph because it's stretching my points up vertically. Now the opposite is true with our fractions. So my vertex is at 0, 0. If x is 1, 1 squared is 1, but I'm cutting it in half. So instead of going up 1, half of 1 is half. If x is 2, 1, 2, 2 squared is 4, but that 1/2 is cutting it, so it's pushing it down, it's shrinking it. And so it is going, if I'm going to reflect these, it is widening my graph, and the smaller the fraction, the wider my graph. Okay. So that demonstrates that there. Now the homework or the book wants us to not only graph it, but to also complete the square. So the first one I'm going to do with you, we are going to complete the square, so more review. End graph, y plus 2x squared plus 12x plus 17 equals 0. Now, the first thing I should mention here is this is in general form. General form has everything on the left, everything together. It's not in perfect order, though. The difference is we are completing the square, so we need to move things around. So I'm going to subtract so that I have y by itself. So y equals negative 2x squared, minus 12x minus 17. And you might have thought, well, it would have been easier to move y, but I can't have a negative y. So step 1, I'm going to factor out the negative 2. That's what we do when we complete the square, out of the first two terms. So I get x squared, right, plus 6x. I'm going to leave a space, and then out here I have minus 17. So it's the first thing you're going to do. Notice I only factored it out of the first two. To complete the square, you take the b term, which is your middle term, is a positive 6. And I do 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So I am adding 9 here. But I have to keep this equal sign true. So whatever I do to the right, I have to do to the left. Now I know this says a positive 9, but I have already factored out negative 2. So if I pretend this was here from the beginning, this would have been a negative 18, right? Because negative 18 divided by negative 2 gives us a positive 9. So I have to put negative 18 on the left. Okay, now we're going to end up moving it back over, but this gives you a better idea of what it will be when I move it back over. So the next part I'm going to do is I'm going to factor x squared plus 6x plus 9. I'm going to factor this, and I get x plus 3 squared. It should be a binomial squared. And then I'm going to have to add the 18 back over, and that gives me a positive 1. All right, so let's talk about everything going on here. This means our graph will point down. And my vertex is negative 3, 1. And so that's all the information I need to graph. I'm going to leave room to the left and on the bottom because I know that my graph should point down. All right, so my vertex is at negative 3, 1. Now, I know it's going to point down, and I also know A is 2, so my values are going to be multiplied by 2. So starting at your vertex is, if x is 1, 1 squared is 1, but I have to multiply that times 2. So 1 times 2 is 2. Now you can build a table, you can use Desmos, but this is much faster. If x is 2, so starting from your vertex, 1, 2, 2 squared is 4, but 4 times 2 is 8, so I need to go 4 more. And then I'm just going to reflect those points across, and there is my graph. Look how beautiful that is. There we go. All right, so we are going to do one more, and then we will be done with the lesson. Wish you guys were here. We'll see if anyone wants to go back to school after all this, right? Number 2. So complete the square. And graph 3y minus x squared plus 2x plus 5 equals 0. All right, now again, notice this is in general form. Sorry, I needed a nice drink of coffee. And I am now going to get this in proper form. So I need y by itself, so that's step 1. So 3y, I've got to move everything over. So plus x squared minus 2x minus 5, right? I moved these 3 terms to the right. Now I'm going to have to divide by 3, but And in order to do that, you should be dividing everything by 3. So here I am, y equals 1/3, my apologies, 1/3 x squared minus 2/3 x minus 5/3. Now I know that looks crazy. I need to unlock my computer. I think it times out after 20 minutes, which is what I've learned. And so I know this has fractions, but don't be scared. You could also get rid of them, but I wouldn't advise it because I need to graph it with that transformation. So I'm going to factor out 1/3 from these first two terms. So y, I'm going to leave a space because I know I'm going to end up moving something over. Y equals, I'm going to take 1/3 out of the first two terms. So 1/3 divided by 1/3 is just 1x squared. How many 1/3s go into 2/3? 2. And it's a negative divided by a positive, so negative 2x. And out here, leave the third term alone. So it wasn't that bad. I'm now going to take, this is where we complete the square. I take the middle term, and I divide by 2, and I square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So I'm adding 1 here. But when on the left side, this is actually, I'm adding 1/3 because 1/3 times 1. Just redistribute it. 1/3 times 1 is 1/3. Now, here we go. We're going to do two things all at once. We're going to factor this. So I keep writing 1/2. 1/3. And this would be x minus 1 squared. And then I would have to subtract this guy back over, right? And negative 5/3 minus 1/3 is negative 6/3, which is negative 2. Look how beautiful those numbers are. You only have one fraction. So I've got a vertex at 1, negative 2. And because that is a positive, my graph points up. So I'm going to graph this now. And I don't need a lot of room because all my values are going to be cut into thirds. Oops. All right, so 2, 4, 2, 4. All right, so I have a vertex at 1, negative 2. Remember, h is opposite because this is x minus, the h is the 1. And then I have a negative 2, and I'm pointing up. So if x is, starting from my vertex, x is 1, 1 squared is 1. But I'm cutting that or dividing it by 3, so I should just get 1/3. The easiest one would be to do 3. If x is 3, so 1, 2, 3. 3 squared is 9, but I'm cutting that by a third. Like I'm multiplying it by 1/3. So 9 times 1/3 is the same as 9 divided by 3. So I am only going to go up 3 instead of 9. And I'm going to reflect those 2 points. 3, up 3. And so my graph looks more like a satellite dish or bowl. Did I grab the pen that's not working? Of course I did. And so there is my graph. We can do one more if that helps. If you understand it, you could fast forward it to what I tell you to skip on the homework, or you could try this one on your own. We're going to complete the square, so for y equals negative 1/2 x squared plus 4x minus 5. All right, so let's set it up. Factor that negative 1/2 out of the first two terms. So you could use your calculator. 4 divided by negative 1/2 is negative 8x So different than what we think, right? I'm factoring 1/2 out of here, so I'm technically dividing each term by 1/2. So this is how many 50-cent pieces go into 4. You're not multiplying by 1/2. That would have given you 2. You're dividing how many halves go into 4, and 8 halves would go into 4. So then from here, right, -8 divided by 2 squared would be 16. So I'm adding 16 here, and I'm subtracting 8 here, because -1/2 times 16 is -8. Now I'm going to factor, so -1/2 times x minus 4 squared. I'd have to add 8 back over, and if I add 8 back over, I get 3. So I've got a couple of things right. This graph points down, shrunk by 1/2, and I have a vertex of 4, 3. So here is my graph. It doesn't need to be very large. All right, so I have a vertex of 4, 3. My graph points down, so I'm using my method, but I'm just going down for the points. So if x is 1, 1 squared is 1, but I'm cutting it in half. So I'm only going down half. If x is 2, 1, 2, 2 squared is 4, but I'm cutting that in half, so I'm only going down 2. Okay. If x is 3, 1, 2, 3, 3 squared is 9, but half of 9 is only 4.5. So if that helps, you see the full graph. And then I'm going to reflect that across. You only should have to do that for one side. And that is my graph. Beautiful, right? For homework 58, we are only skipping a few. Let me confirm with my homework sheet because I do all the homework. Oh, never mind. So skip number 7, 8, 20, 22, and 27. Yep, and thank you.